We're going to go over the last 2 pages of our Chapter 1 notes today, and we'll have a special added feature of the marching band outside playing and getting ready for their field show, if you want to listen to that in the background. Anyways, we're going to talk about section 1.7 today, and today what's different than the other days is we're actually going to be solving quadratic equations, and equations have an equal sign in them. And what we're going to do is we're going to be factoring like we have been doing the other 2 days. And but then at the end we're going to let x equal some value. So remember, a quadratic equation, we have to get it written in standard form first to get the x squared term first, the x term second, and the constant term last, and make it equal to 0. That's standard form. And if you want to solve a quadratic equation by factoring, you have to get it into standard form first. So you got to get it into this form. And then the second step is to factor it like we've been doing the past couple of days. And then you're going to solve by setting each factor equal to 0. And if it's not factorable, we're going to use the quadratic formula, but we won't do that yet. We'll save that for next month. So first of all, we have this quadratic equation. It's in standard form because the x squared is first, the x is second, the constant is next, and it's equal to 0. So what we have to do is factor this by doing factor in, factor out. 5 times negative 7 is negative 35, and the factors of negative 35 that add up to 34 are positive 35 and negative 1. So we're going to open up 2 empty sets of parentheses, put a 5x in the front, and a plus 35, and a minus 1 in the back, and don't forget that we have to divide the whole thing out by 5. And this becomes x plus 7, when you divide each one of these out by 5, times 5x minus 1, but this is an equation, so you got to set it equal to 0. And that means you set each factor equal to 0. You say x plus 7 equals 0, because 0 times anything is 0. And then you set 5x minus 1 equal to 0, because anything times 0 is 0. And then all you have to do is subtract 7 from each side, so x is equal to negative 7. There's one answer. Add 1 to both sides, you get 5x equals 1. Divide by 5, and x is equal to 1/5. So there are your solutions. Now this is different because we're solving for x this time. In this second example, we don't have it in standard form, so you're going to have to subtract 6x from each side. And it goes 10x squared minus 6x is equal to 0. Well, to factor this, you have a GCF. The greatest common factor is 2x. And then what we're left with is 5x minus 3. If you want to distribute this, you should get this back again, and that's equal to 0. Now we have 2 factors. We have a factor called 2x. We set that equal to 0, and we have a factor called 5x minus 3, and set that equal to 0. Dividing both sides by 2, 0 divided by 2 is still 0, so x equals 0 is one solution. And now we're going to add 3 to both sides, and you get 5x is equal to 3. Divide by 5, x equals 3/5. So there are your 2 solutions to the second problem. And in the third problem, we have the difference of 2 perfect squares, which will be opening up 2 sets of parentheses, 4x in the front, the square root of that, one's a plus, one's a minus, and the square root of 9 is 3. So you set each equation equal to 0, 4x plus 3 equals 0, 4x minus 3 equals 0, subtract 3, divide by 4. So x equals negative 3/4 is one answer. In this case, you add 3, 4x is equal to positive 3, and divide by 4, x equals positive 3/4. So there are your 2 answers for number 3. In number 4, we've got to set it equal to 0, so we're going to subtract 20x from both sides and add 25 to get everything over on the left. So that becomes 4x squared minus 20x plus 25 is equal to 0. This is a factor in, factor out because of the 4 on the front, so 4 times 25 is equal to 100, positive. What are the factors of 100? positive 100 that add up to negative 20? Well, you can go through several factors of 100, but you'll finally come up with a negative 10 times a negative 10 is a positive 100, and they add up to negative 20. In your open sets of parentheses, you're going to put a 4x in both. You're going to put a minus 10 and a minus 10, and don't forget that you have to divide out by 4. But 4 doesn't go into 10 evenly, so that's got to be split up into 2 times 2. And now the 4x goes into, or 4x divided by 2 is 2x, 10 divided by 2 is 5. So this becomes a 2x minus 5, and this is the same thing. This becomes a 2x minus 5. And if you ever have the same factor multiplied by itself, you can just call it 2x minus 5 to the second power. So now we have just one, we really have the same factor multiplied by itself. So we can just set 2x minus 5 equal to 0, add 5 to both sides, and divide by 2. So we really only have one answer. Most quadratic equations have two answers, but sometimes we have just one answer because it's a repeated answer, 5 over 2. And then this last example, we have to subtract 4x from each side, and we have to make sure the x goes in the middle. So we have 2x squared, the minus 4x goes in the middle, and the minus 30 goes on the end. Well, again, we have a GCF of a 2, so we're going to pull the 2 out, and we're left with x squared minus 2x minus 15. So now what we do is find the factors of 15 that add up to negative 2, and they are negative 5 and positive 3. Now, if you have just an integer or just a constant on the outside of your parentheses, what you can do is you can divide both sides by it. Remember, if you have an x here, you would set 2x equal to 0. But this time, there's no x on the outside, it's just a 2. 2 divided by 2 will cancel out, and 0 divided by 2 is still 0. So what you have is, you have x minus 5 times x plus 3 equaling 0, because the 2 divided out. And now you set each factor equal to 0. X minus 5 equals 0, x plus 3 equals 0, and add 5 to both sides. X equals 5. Subtract 3 from each side, x equals negative 3. So you have two answers there. So those are quadratic equations, and you should have done those in earlier math classes. Now the next section, and the last page of our notes, because pages 11 and 12 are just some reference material for you, we're going to solve quadratic inequalities this time. And remember, inequalities are anything with less than or equal to, greater than or equal to symbols. So we have 3 steps to follow to solve an inequality. First of all, just like we did in the last page, we're going to find the roots or the solution of the corresponding equation. And I'll just say this is like page 9 of your notes, the previous page. And then once you get those 2 answers, you're going to mark them on a number line. And you're either going to have open circles if it's less than or greater than, or filled in circles if it's less than or equal to, greater than or equal to. And then if your original inequality is less than or equal to, you're going to shade in between the 2 roots. If it's greater than or greater than equal to, you're going to shade on the outside. And these are going to look like the absolute value inequalities that we did in the beginning of the chapter. Or if you can't remember, if you have a hard time remembering that the less than means between, the greater than means to the outside, what you can do is pick a test point in each of the intervals that'll appear on your number line and see if that makes the original problem true. And if it does, you're going to shade inside that interval. This is an alternative method to A and B. So let's go through some examples to see what this all means. We have a quadratic inequality, and we have to indicate our answer in 3 different ways, if you remember the 3 different ways. So the first step is to find the solutions. We're going to pretend this is an equation, so we're going to just factor this into x minus 5 times x plus 3. And we're going to pretend just for a minute that it's equal to 0. And so we're going to say x minus 5 equals 0, x plus 3 equals 0. So x is equal to 5 and x equals negative 3. So that's step 1. Step 2 says, mark those two numbers on the number line. Make sure the smaller one goes to the left. So you have a negative 3 and you have a positive 5. Mark those on the number line first. And then we're going to have filled in circles because this is greater than or equal to. So just fill those circles in. And then because the original problem is a greater than means you're going to shade to the outside. And one of the tricks that I teach kids to remembering greater than, these are like oars on a boat. If you can imagine that this is like a boat and these are your oars on the boat and you're rowing the boat, if you can see it that way, sometimes you can remember the greater than. Now symbolically, this part of the number line means x is less than or equal to negative 3. Greater than has an or. X is greater than or equal to positive 5. Those are using symbols. The interval notation means the x values are going back to negative infinity and they're coming up to negative 3 with a square bracket because of the filled in, with a u, and then a square bracket because it's a filled in circle, 5 all the way up to the end of time with the open parentheses. The next example, if you want to factor this, the factors of 8 that add up to 6 are plus 4, plus 2. And if you want to go through a shortcut, hopefully you know by now if you don't have a coefficient in front of the x, your x is just going to be equal to the negative value of this and the negative value of this. So we have negative 4 and negative 2. So negative 4 is less than negative 2. Make sure you write that in the right order. This is strictly less than, so it means you got open circles. And because it's less than and sandwich, we're like sandwiched in between these two numbers. You're going to shade in between here. So symbolically, you're going to bring the negative 4 down. It's less than, all these values are the x values, which are less than this bigger number of negative 2. And in interval notation, because we've got open circles, we have rounded parentheses, negative 4, comma, negative 2, rounded parentheses. So you're done with that problem. The next one you're going to have to get in standard form by subtracting 2x and subtracting 10 from each side. So you have an x squared. Negative 4x minus 2x is negative 6x. Negative 6 minus 10 is negative 16. And we're going to pretend for a minute that it's an equation. The factors of negative 16 that add up to negative 6 are negative 8 and positive 2. So because there's no coefficient in front of the x, we can just negate this. X is equal to positive 8 and x is equal to negative 2. Well, I haven't given you a number line, so you're just going to have to draw it yourself. So we got a number line. The negative 2 is smaller than the positive 8. Now this is less than or equal to, so we have filled in circles. And because it's less than or equal to, less than, we're going to shade in between here. This is graphically, part A. Part B symbolically means negative 2 is less than or equal to x is less than or equal to 8. All those x values are in between those two. And then in interval notation, because we have filled in circles, we have a square bracket, negative 2 all the way up to positive 8. And then the last example, we have a factor in, factor out problem. 2 times 3 is 6. The factors of 6 that add up to 7 are positive 6 and positive 1. So we have a 2x in both parentheses, a plus 6 and a plus 1. And we have to make sure we divide it all out by 2. So this becomes x plus 3, and this becomes 2x plus 1. equals 0. Well, this x value is equal to negative 3, and if you subtract 1, you get 2x equals negative 1 if you set this equal to 0, so x is equal to negative 1 over 2. So now we have our two roots, negative 3, negative 1/2. Well, negative 3 is less than negative 1/2. The original problem is just a greater than, so we have open circles. In greater than, we're going to put our oars on a boat. Greater than. And that is our graphic solution. Symbolically, this means all the x values are less than negative 3, or all of those x values are greater than negative 1/2. And then in interval notation, it goes all the way down to the negative end of time and up to negative 3. Union, the negative 1/2, goes all the way up to positive infinity. And that's it for Chapter 1. See you tomorrow.